Hello everybody, my name is Sanjit, and welcome to our AP Calc AB course in our organization Learnable. I'm the lead educator in this math course, and I have taken AP Calc AB in BC and have received 5s on both exams. And I've also taken linear algebra. This is just for credentials. I'm a senior right now, and I will be helping you learn calculus, and I hope you find it as fun as I did. I want you all to score well on your exams and your classes, so please watch our videos to learn and grow your skills in calculus. If you're learning just for fun, I strongly encourage you to start this course and fulfill your curiosity and learn more and more math. As we learn this unit of calculus, the first unit, we will first learn the foundation of mathematical applications in this course. Limits and continuity. Think of a limit as what it sounds like. Think of it like the numerical value that a function approaches as its input gets closer and closer to a designated number. So, first, you can think of it like this. Look at this graph of this function 1 over e to the x. Okay, let me draw this. Okay. So as you can see, it's like flattening out here on this part. So what do you see as the x value approaches a larger and larger number? So as x goes towards infinity. So what do you see? It can be seen that the y value also approaches a number, a finite number, that it will never reach, but it will get as close to as possible. So it will get closer and closer forever, but it will never touch that exact value. This value over here is y equals 0. You can see that it will always go near y equals 0. It will flatten out in the end, but it will never reach y equals 0. This is an important concept. But this isn't the only way that limits can exist. The function we are given may also provide a designated number for which the x value cannot exceed. For example, f of x equals to 1 over e to the x as x approaches 0. So what do you see as x approaches 0? Well, from the left side, I can see that the function is approaching a value of 1. So y is approaching 1 from the left side. From the right side, if you look at it, so from the left side, y is approaching 1. And from the right side as well, you can see that if you go left, you can see that y also approaches 1. So, I will show you there is a way to express this mathematically, and this is called the limit notation. Let me give you an example on how to write this. To represent the situation that we showed before, all we have to do is write it in limit notation, which I will show you right now. Okay, so there is a way to express this mathematically, and this is how you do it. So let's say we want to find the limit as x approaches 0 of the function 1 over e to the x. So we already figured out that as x approaches 0, from both sides y approaches 1, which makes the limit as x approaches 0 1. So this is how you write it for this. The limit, you always write the limit, and below that you always write the condition. So as x approaches 0 of f of x. So what is f of x? It's 1 over e to the x. So I can just write it as it is over here. Okay. So once I do this, what does this value equal? This equals 1. So y equals 1 as x approaches 0 from both sides. So this will be equal to 1. Okay, here are a few more examples. Why don't we try the one we were talking about before? So as x approaches infinity, what does y approach? Well, we already found that out. Y approaches 0. It will never touch that value, but it will get as close as possible to it. So this is how you do it. For that function, as the limit as x approaches infinity, since it's going bigger and bigger, the y value will never exceed this number, 0. It will go as close to it as it wants. but it will never ever reach it. So those are a few examples. I will give you one for you to try out on your own right now. So let me okay, one sec. Okay, now let's try x squared. This is minus 2, so this is 4. Okay. So hope I drew this well. Okay, there we go. So this is a graph of x squared. F of x equals x squared. So now what I want you to do is to find the limit. Wait, let me position screen. Okay, to find. Actually, wait. I want you to find the limit as x approaches 2 of the function f of x, which in this case is x squared. So now what do you have to do? We use the same rules that we used before. We have to see what it approaches from the left and the right side. So as you can see, as when x is equal to 2, this area, it's actually this dot right here, you can see that the function approaches from the left side, from this side, it approaches 4, and from the right side it also approaches 4. Okay, now so what does this mean? This means that the limit as x approaches 2 of x squared, which we can just write it as f of x, or just easier, is equal to what number? 4. Since the function approaches 4 from both the left and the right when x approaches 2. Now that we've gotten to the outline of what a limit is and what it does, it's important to understand it's important to understand a large pillar of what is the byproduct in the application of limits. So we're going to talk about continuity. So in order for a function to be continuous, it must have no holes or breaks in it. So one example of holes or breaks would be like this function right here. So this will have an open circle here, and then from here it'll continue. So it'll keep continuing forever. So as you can see, these 2 points don't touch each other. For a function to be continuous, both the points should touch. Something like this, like this. All the points touch, and none of them have like a gap or a jump or a hole. A hole would be like this kind of function where the value at 2 doesn't exist. So in order for a function to be continuous, it must obey 3 rules. So the first rule, continuous function rules. So the first rule is that f of a should be defined. Remember when we saw the graph over here with the hole in it in the middle? See, and this is at x equals 2, right? So that means that at x equals 2, this function has no value, which means it's undefined. So for a function to be continuous, f of a should be defined. The second rule is the limit of f of x as x approaches a should exist. What I mean by this is, let me show you. Suppose we have a function that has a break in it. Let's say this function right here. Oops. Say this function. Okay. Wait, why is the color changing? Okay. Okay. Let's say this function right here is f of x. So, the limit of f of x should exist when x approaches a. Suppose a is equal to -1 in this case, so x equals -1. So, if this is the case, then if the limit should exist, from both sides, they should be approaching the same value. For example, in a function like this, both sides approach this exact value right here. But in this function right here, you can see that they approach different values. From the left side of the function, the y value, the f of x approaches 1, and from the right side, this way, f of x approaches 1, 2, 3. So these approach different values, which means that the limit limit of f of x as x approaches a is not continuous. So that's the second rule. The third rule is that the limit as x approaches a of f of x should equal the point f of a. So what does this mean? Remember when I said f of a should be defined? Like a function should have no holes in it. This means that f of x, the limit as f of x approaches, the limit as x approaches a of f of x is equal to a. So basically it's like this. We can have this kind of function, maybe a linear function, let's just say. Let's suppose this is, let's say a is equal to 0 in this case. So over here, let's just suppose that when a is 0, f of x equals 2. I've just drawn this badly. Okay, so when a is 0, the limit as x approaches a, so the left side, it approaches 2. From the right side, it also approaches 2. So that means the limit of f of x is equal to 2 as x approaches a. And f of a, what's f of a? So f of 0. F of 0 is 2. Since the limit is equal to f of a, this means that it's the final rule that the function should be continuous with. So that's all we have for today. So in the next video, we're going to be building up on this concept and dive into estimating limits of a function on graphs and tables and using algebraic notations. So please watch the next video. If you want to score well on your exams, you should watch all our videos, and please subscribe. Don't forget to subscribe, as it would help us out a lot. And thank you.